mathematics anxiety unfortunately affects working memory as well, and this is one of the pathways on which we think mathematics anxiety actually interferes with mathematical learning. So how do we know about this? Well, okay, one of the things that were obvious was that people with high math anxiety often trade accuracy for speed. So children might just want to get over the math homework as quickly as possible because it triggers all these difficult feelings. So this is often called local avoidance. So by speed, they minimize the time they have to spend on doing math. What's also obvious is if you actually look at the types of problems, and one of the problem types people have looked at is addition and subtraction, with carrying and borrowing, in comparison to when you don't carry or you don't borrow, is that children with high math anxiety, when they actually engage with more difficult problems, that they are slower and less accurate than children with lower math anxiety. And this started the idea that we know that these problems for carrying or for borrowing load on working memory, that you need extra working memory resources to solve those more difficult problems. So that started that interest in the relationship between math anxiety and working memory. Now, you're probably familiar with one of the famous working memory models by Badley and Hitch, 1974. There are different working memory models, but this one I think works very well for mathematical learning. And there the idea is that we have a central amodal sort of part, which is called the central executive, which helps us to decide where we allocate attention, which helps us keeping track where we are in a problem. And then we have two modality-specific stores. A verbal working memory, in which, for example, if the teacher says the problem verbally, we're rehearsing the numbers in our head, 29 plus 3, 29 plus 3, 29 plus 3, with a very short term. And we also have visual spatial working memory, which is, for example, remembering the Arabic digits on the sheet, or some problem that is written down and navigating in space. And you can imagine that when you hear a problem that you have to solve, and at the same time you might have to retrieve and remember intermediate results, so 23 plus 9, you do 9 plus 3, is you have to retrieve that from long-term memory is 12, but you have to remember what was the original problem, 23 plus 9, and so on. And then you have to remember the 20 still, that there's a lot of switching and allocating attention, maintaining information in your memory while you're processing, retrieving, calculating. So these are typical working memory tasks. And any deficits in any of these components can have effect on mathematical learning or arithmetic performance. And how would you measure children's verbal working memory? Typically, you ask people to do a digit span task. So they hear a number of spoken numbers and they have to repeat the sequence of digits back to them. And here I've put some links on where you can test yourself on those tasks. Visual spatial working memory are tasks, for example, where you have 9 blocks in front of the child and you tap a sequence of those blocks and they have to repeat that sequence. So in space, visual spatial tasks. Now what we know is that working memory resources are often disrupted by anxiety. So adults in this case with high math anxiety showed a lower working memory span for computation spans, so something to do with arithmetic, but not for language-based spans. So those working memory resources are only depleted when their math anxieties arise. So in situations that have to do with math context, they're using those additional resources to manage the anxiety, and so less is available. So here's an overview how this might work. So possibly children have difficulties with math or even processing of spatial information that might lead to lower math achievement, that might then lead to math anxiety. There are also social influences that influence perhaps lower math achievement and math anxiety, peer pressure. Some people are more for some children it's more important to look well in front of their peers and more sensitive to peer groups. Math anxiety will lead to avoidance, and also math anxiety, when you have to manage it, when you're solving math tasks or you're in a math classroom, leads to an online working memory reduction. which both avoidance of math lessons or of math homework, whether that's global or local avoidance, and the online reduction in working memory capacity to deal with it, lead to a lower math achievement. So even if people don't have these numerical difficulties in the beginning and they have math anxiety, the effects of avoidance and working memory reduction will probably lead to lower math achievement. So what do we know about risk factors for students or children to develop math anxiety? We know that there are relationships between students' own perception of math ability and their math anxiety. Also, what they feel how important high performance is. Perceptions about how important math actually is. I already mentioned that children who have a higher susceptibility to public embarrassment are more likely perhaps to develop mathematics anxiety. There's a relationship with mathematical ability or working memory capacity. So children who have a lower than average math ability or working memory capacity might be at a higher risk to develop math anxiety, but not all children do, right? So we have children who have severe math difficulties or who have lower working memory capacity who do not develop mathematics anxiety. Of course, as you know, supportive teachers are really important. And there might be some evidence that when teachers have high math anxiety, that this might trigger some sort of anxiety in some children who are more at risk at developing this.